Aloha, Richard Halverson here. This is ITS128, and today is October 19th. And let me share my screen. Here we are. And so we must be in here somewhere doing functions. October 19th, functions. Okay. Let's see where exactly that is. Let's see. Oh, Replit, that's right. Let's use Replit some more. I'm gonna just sign in right now. Replit, it. Replete. I don't even know what that means. Resplendent. Okay, it must be logged in for me already. Because these look like my little programs here. So I encourage you to get one of these accounts because you can use it to help you debug your code. You're able to look at your variables when you debug your code. So I'm going to look at my REPLs, and I've got a test folder in here anyway. So I'm going to use that, and we are in section. We're going to do section 6.2, and we've done lab 6.18. So let's go to our textbook. Six point two. Okay, so I guess we've looked at these print functions, and all this is functions that print to make it convenient for you if you've got a whole bunch of stuff to print out and you don't want all these lines of text that are just some text that you're going to print out on the screen to take up all this space in your program when you're trying to write your code around it. And it helps you keep your code more organized. Have I not done this? Let's see, here's a print function. What are we supposed to do here? Let's try it, 6.2. Oh yeah, I think the last thing we did was this menu system. And we got this menu to run on Replit. Okay, so go look at the last video to see that. Okay, so let's do this challenge activity. Start. What am I supposed to do? Age to print is 21, and then we call this function here called print age, and it prints out he is 21. Enter. Well, that's just too easy. Okay, what's this one? Define a function, print feet inch. Did I really? Guess I did not do these. Oh, I see. So I'm supposed to. Okay, so I'm supposed to define a function that prints you read in it takes in a 5 and an 8 as the function takes 5 and 8 as two parameters, and it prints this out. Oh boy. You know, I'm going to just let you do this one. This is just too easy. All right, let's go to dynamic typing. Okay, what dynamic typing has to do with is that sometimes when your function is called, you may call it with where the parameters, well, the arguments are numbers, and other times you might call it where the arguments are strings. And if the function is able to handle it either way, then it's a polymorphic function. So here's an example of a polymorphic function. So here, okay, so here it prints out this thing adds x and y, and this is the function, and it's a plus sign. And you know that if x and y are strings, then the plus sign will concatenate the two strings. And of course, if x and y are numbers, then x plus y will add the two numbers together and return the sum. So all this does is this is the function that's called, this is calling the function with the two arguments which come in here and then execute this. So we already have a check mark here. I guess we must have done this already. Okay, so that's dynamic functions behavior. Being able to add together different types is a concept called polymorphism. Polymorphism is an inherent part of the Python languages. All languages have this now. It used to. For example, the multiplication operator, if you're doing a number times a number, you're just multiplying the number. But if you're doing a string times a number, it means repeat the string this many times. So this. Okay, so the type of num can change depending on the value it references. So what this means is that you can assign, let's try this replit thing here. I'm going to try something. No, that's okay. All right, so I'm going to wait until I get a larger example before I go over here, because once I go over here, I'll probably be here for a while, and I want to get through some of these sections here. Not like last time when we only got through one section. All right, so the concept of dynamic typing is that you can, in Python, you can use a variable to store a number, and then some other time you can use that same variable to store a string. Okay, and so the typing of the variable is dynamic. It can change. Okay, and the reason that this is so easy to do in Python is because really this is like the address of an object, and this sort of connects to an object, and this object can change. And every time you assign a variable a new value, you're actually assigning it to a different object. And so in Python, it's very simple to do this. In other languages, it's not simple, and they don't do it. Static typing is a feature in languages where you're writing large programs and with teams of members, and with static typing, you define a variable as a particular type, and you have to use it that way, and you can't just change it along the way. You have to define a different variable if you want to have something different. So dynamic typing is, I guess, a feature in Python, just as static typing is a feature in these other languages. So polymorphism refers to how an operation depends on an operation. How an operation depends on the involved object types. Yes, true. A programmer can pass only string arguments to a user-defined function. Well, we just saw in the example of above. That's not true, so I'm going to say false. Okay. Static typed languages require that the type of every variable is defined in the source code. Yeah. Yeah, that would be true. And a dynamic type language like Python checks that the operation is valid when the operation is executed by the interpreter. If the operation is invalid, a runtime error occurs. Yes. Yes. See, in statically typed languages, the compiler can tell if there's going to be an error because everything's defined at, it's at, at compile time, and they don't change. So when you try to execute the program, the interpreter or the compiler takes a pass through your program to see if there's any syntax errors, and a compiler for those other languages that are statically typed can detect errors, assignment errors like that. In Python, it's got to be a runtime thing because, who knows what the type of the variable is at the time that the operation occurs. Yeah, sure, okay. Reasons for defining functions. Okay, so these are just a bunch of general reasons for defining functions that you begin to understand very clearly after you write a bunch of code and you find yourself copying and pasting a lot, which is a perfectly valid thing to do. But you may want to, if you find you've got a lot of like redundant code like we have in this example here, then that's a good candidate to consolidate and turn into a function. So you're just going to be calling a function instead of calculating the circle area each time over on the left. So we have improving readability. It's a way of sort of chunking your program, and avoid writing redundant code, factoring out a unit conversion calculation. Okay, so let's see what this one looks like. Write a function so that the main program below can be replaced by the simpler code that calls a function named this. So the original program is this, and we want this to be turned into this. This doesn't seem that hard. Def this. In fact, I'm just going to do def this. Colon. And I don't like these big long things, so I'm going to do MPH. And I'm going to do min. How about mintrav? Okay, so these are inputs. This goes there because of that, and this is here, and when it's called, it's going to start being referred to as this. And then we have this code here. And let's put that right here. I'm going to do Control V. And of course, this has to be indented. And we want to, the miles per hour, which is this, is going to be, well, we can just do this, MPH. And we can just do this, copy, paste. And then instead of printing this, we're going to return this. Let's see. Okay, so I think this will work. So it asks the user for a miles per hour. This is the original main program where this executes. And the first thing it does is it asks the user for miles per hour. And then it asks the user for minutes traveled. And the reason this is here, of course, is because when the user types it in, it's going to be a string. You know, whatever the user types on the keyboard, it goes in as a string. And if really what you want to do is interpret those digits that come in as a number instead of a string of characters, then you have to use the float function. And so this converts that string into a actual value, numerical value, and that's what gets stored into this variable here. Same with this. And so it asks the user this, it asks the user this, it computes the miles traveled because it's divides by miles traveled, divides by 60. That's the hours traveled. Well, this is the minutes traveled divided by 60 gives you hours traveled, of course. If you travel 120 minutes, divide that by 60, and that equals 2 hours. And then you multiply the 2 hours by how fast you're going, miles per hour. If you're going 60 miles per hour times 2 hours, that equals 120 miles or whatever. And then this just prints out the 120 miles using this format right here. Floating point number, I guess, means a decimal point. And so, so this is the 70.0 is the miles per hour, and 100 is the minutes traveled. And after this calculation is done, it prints out miles colon this. And so here, you know, we are just we're turning this into a function, and this should work. So you can try that out. Okay, writing mathematical functions. A function is commonly defined to compute a mathematical calculation involving several numerical parameters, returning a numerical result. Yeah, so you know, here's an example of a function that's going to convert a US length measurement to centimeters. So it reads in feet and inches, you know, like maybe your height in feet and inches, and converts it to centimeters. And this is how this does it. And what are we supposed to be seeing here? We're supposed to be seeing that this is a function. This is a conversion function. Is this what we're talking about here? Mathematical functions, temperature conversion, square functions, calling functions in expressions. Yeah. Yeah, you can call functions in expressions because what returns is something that fits right in. That's closure. Mathematics, that's called closure. So there's functions here, and this is a function which just calls a function that is imported from the math, importing the math module. This is a function that's going to find the maximum of two numbers that you give it. And why don't we see if this... So what are we supposed to do here? We're supposed to assign max sum with the greater of this and this. Plus the greater of this and this. Use just one statement. Call twice. Oh, I see. So we're supposed to, plus meaning add, I see. So So the first thing we're going to do is take the larger of these two numbers and add it to the larger of these two numbers. So this would be 10, and this would be 7. So 7 plus 10 is 17. So what we're supposed to do is we're supposed to notice here that there's this, we have this function which takes in two numbers, number 1 and number 2, and it returns back the larger of the two. So the first thing it does is a test to see if okay, so it defines a variable that's going to it's going to store the larger of the two. We set it equal to 0. Now this assumes, of course, that the numbers coming in are greater than 0. If the numbers coming in are less than 0, then this isn't going to work. If we wanted it to work, this has got to be initialized to the smallest smaller than whatever, I guess smaller than the largest number that would be read. This is not a very good function. There's a much better way to write this function. Is the purpose of this okay? Well, anyway, so this looks at this test to see if the first one is bigger than the second one. If it is, then it sets a max val equal to the first one because it's bigger than the second one. Otherwise, it sets max val equal to the second one. So if the two numbers are equal, then max val is equal to the two, and it's still the largest one. So that works. Max val would be, if the two numbers are equal, then max val gets set to that number in this assignment statement here, and then we just return max val. So we're supposed to write something that adds these two together. Isn't that the same as? Well, that's the same as this, sort of. Here we have two functions. We have a function which will square an argument, and we're going to use the same function twice. So we take 7 squared plus 9 squared, and that's what that ends up being, and then we print it out, and it's that. So you can do the same thing down here. That's pretty straightforward. You put it right here, and it would be max sum equals these two functions. The first one with these two arguments plus the function with these two arguments. Modularity allows more complex functions to incorporate simpler functions. Cylinder surface gets radius and height. Cylinder surface volume gets radius, and that's this one. And this function relies and calls on this function, which is calculates the circular base. Okay, so this is to calculate the cylinder volume and surface area. Cylinder volume so this function calculates the cylinder volume and the cylinder surface area. Okay, it calculates those two things, and they each use this one function which calculates the cylinder's base area. So the function which calculates the cylinder volume, which is this function, uses the function which calculates the cylinder base area, which is this function. Similarly, the function that calculates the surface area of the cylinder, this function, also uses the function which calculates the circular base area. So that's what this is about. Modular functions. So you modularize these things and it helps you write correct code that people understand. Okay, what's this one? Volume of a pyramid using modular functions. Okay, define a function, calculate pyramid volume. Calculate pyramid volume and returns the volume of the pyramid with a rectangular base. Okay, well, let's see. So calculate pyramid volume equals this. Calculate pyramid volume. I wonder if this is a good one to use. It's not too late. So we are writing a method that looks like this. Copy def that colon. And I'm just going to use the same variable names. It doesn't matter. And I need to return. I got to return a volume, and I'm going to use this equation here. Okay. So that equation is, well, I'm going to create a variable. Volume, which I'm going to return, I'm just going to do it this way, equals the base area, which it looks like is this, equals the calculate base area. And I need to put in a length, and that's probably this length. So I'm going to do length. Width. So that's this calculate base area times, so I can do times the height, which is this, height, times 1/3. And just do times 1 divided by 3. That works. No, we're supposed to watch out for integer division. Okay. Yeah, so we don't need to do the times 1, do we? It's math. There. And then we want to return the volume, I think. Is this all we need to do? So let me, I'd like to see this run. So I'm going to use this as, this is this function here, this one. Copy. Now I'm going to go into here. And I'm going to do a new one. And I'm going to use this. And I'm going to name it something like this. I don't know. That's kind of a long name. Volume. Volume of pyramid. Pyramid volume. How's that? Create. Here I am, and I'm going to copy my solution here, paste it here. And before I do anything else, I'm going to put something here. Enter a length. Enter length of pyramid. And I'm going to say enter width of pyramid. And I'm going to say enter height. And then I'm going to say that's fine. And then I'm going to say return base volume, return volume. Okay, so why don't I just, well, I'm just going to run this now. Enter length of pyramid. Okay, so let me give me some good data here. 4.5, 2.13, 4.5, 2.13. 4.5. Did I say 3.1? I said, I said 2.13. 2.1, doesn't matter. 3. Will this work? Okay, I'm going to run it again. 4.5, 2.1, 3. And I get that. Is that close to what the answer is? Yes, 9.45. And why does it look like that? I don't know. Okay, so that works. Right. Anyway, so all right. So anyway, so you can is this a challenge? Yes, so you can submit that. All right, stubs are a way to you know, when you're just, you know, did we talk about the incremental development? I think we did, where you know, you're writing your code, and let's say you're doing this, you're writing something like this. Let's say you're writing something like, where is the function within a, yeah, here, where you you know, where let's say you write your code, you know, top-down structured programming. That's what they used to tell us. Those were the how they used to say we should develop our code back in the 80s and 90s. That was the last century. Where it's you know, stepwise refinement. So you start out with your code, and it's just this. It's just this, and this has not been defined yet, and this has not been defined yet. But to actually test this code or to run it, you have to you know, you have to have something there, right? So what you do is you calc cylinder volume. So you create a def calc cylinder volume, but then you just put a pass, I guess, and so that's and then the reason you do that is because when you start out, you aren't interested in debugging this thing. You're interested in debugging, you know, this thing. Okay, and now this is a very silly, stupid example, but you know, there could be, you know, like a bunch of code there with some loops and ifs and stuff, and it's calling a bunch of functions like this. You know, you're being all modular about it, and you want to test the outside of the code. And then once the outside, that structure works, then you're going to go in and actually write this and test that. And when you're testing that, you can use your outside code to test, you know, those functions. So that's what I think that's what talk about with stubs. So here, yeah, you can put this pass here. So programs are typically written using incremental development, meaning small amounts of code are written and tested, and then more. And to assist in incremental development, programmers commonly introduce function stubs, which are function definitions whose statements haven't been written yet. So the benefit of a stub is that the high-level behavior can be captured before diving into the details of each function. So anyway, and one approach is to use this pass. You know, another approach is to say, you know, this is the function. Say, you know, just print this out and then return something. Sometimes you might be looking. Sometimes for the outer code that's using this to work, you have to return something. And also use, this is 128. I guess we don't have, we haven't talked about interrupt. We don't have, oops, how did I do that? Functions. Yeah, we haven't talked about exceptions yet. We are down here. But when we do talk about exceptions, we'll be able to, you'll be able to raise an exception, and then there'll be an error here. Bing, and but you can keep control of it with exceptions. It displays it just displays that out, but then goes on. It doesn't stop your program. This will stop your program if you just raise the exception, raise this without doing anything about it. Then it'll just cause an error to occur. An error message to appear, and your program stops. So I mean, maybe that's how you want to do it. Incremental development may involve more frequent testing, but ultimately leads to faster program development. Yeah, I would say that's probably true. It's like change something small, test, change something small, test, change, rather than changing a whole bunch of stuff and you're running it and it doesn't work, and you got to decide what to do. I mean, and it may not be obvious if you just recently, or if what you're testing is a whole bunch of code that you, like a page of code, and then you try to test it and it doesn't work, and you're not sure where to start. So that's what this incremental development works. You start out with a blank page and you just put little code in there, and you sort of build it out that way. The main advantage of function stubs is that they ultimately lead to faster running programs. No, it doesn't have anything to do with the speed of the program. A pass statement should be used in a function stub when the programmer wants the stub to stop program execution when called. No, the pass statement is what you use when you want it just to continue. That you don't do anything, just return and come back and continue. If you want the program if you want to stop the program execution, then you use this raise the error here, raise this exception. All right. Raise keyword are explored elsewhere in material focusing on exceptions. Okay, so here's a challenge activity. Define stubs for the functions. Each stub should print this, followed by a new line, and should return -1. Okay, each stub must also contain the function's parameters. Well, sure they do. Otherwise, it won't work. I see. So I'm supposed to write a def get user num, and it doesn't look like it's got any parameters. So I'm supposed to write something there, and okay, so this is wrong. I'm supposed to put something else there, and then I got to do a def compute AVG with 2 parameters, P1 and P2. And then that's going to be something also. Okay, and so and what are we supposed to do? Oh, it's just supposed to print this out. So so anyway, instead of this, you gotta put something else here. Instead of this, you gotta put something else here. I think that's pretty much all you gotta do to fix this. To do this, on a return. Oh yeah. You put a nice print statement and whatever you got to return. All right. So anyway, you can fix that. Functions with branches and loops. Well, of course, there's no reason why functions can have anything. A function's block of statements may include branches, loops, and other statements. The following example uses a function to compute the fee charged by eBay when a customer sells an item online. All right, so we have a function here, and there's a price, and so I guess this is pretty complicated. I wonder if this is true. Calc eBay fee. Copy. I know I didn't have to do it this way, but this one. Calc eBay fee. Paste. And we're supposed to, what are we supposed to do here? Oh, this is just, this already works. Is there a, some, okay, for any call to calculate how many assignment statements will execute. Okay, so let's go through this. This is a good exercise. Okay, so a sell price comes in, and before it does anything, it assigns these values equal to these variables. It just assigns these values equal to these variables, and these values are going to be used down below, but we want to refer to these values by something more descriptive, so that's why we do this. And now the first thing we do is we check if the selling price is less than 50 cents or dollars. Probably dollars. Yeah, dollars. If the selling price is less than $50, then we multiply the selling price by this P50 number, which is 13 cents. And right off the bat, the fee starts at 50 cents. So that's the initialization of the fee is 50 cents. And if the selling price is less than $50, then we multiply the selling price by 0.13 and add that to the fee, and then that's the fee. If the selling price is between $50 and $1,000, then it is the 0.05 value that gets multiplied by, ooh, this is complicated. So the first $50 is the fee. It is the first $50 is still the times 0.13 amount added to the fee, but then from $50 up to $1,000, or the price of the thing, we use this 0.05 multiplier, and above that we use a 0.02 multiplier. Above 1,000, it's a point. So for the first $50, it's a 0.13 multiplier. For the next $950, from $50 up to 1,000, it's a 0.05 multiplier, and after that, it's a 0.02 multiplier. Okay, so that is that's the algorithm. For any call to this, how many assignment statements will execute? Well, let's see, 1, 2, 3, 4, and then either this one or this one or this one, 5. Very good. What does this return if the sell price argument is 0? If the sell price argument is 0, then it's going to be just the fee. because this is going to be 0. Doesn't matter what this is if this is 0. Anything times 0 is 0. So this whole thing is 0. So we're just where we started, and phi starts out at this, and so it's going to be 0.1 point. Oh, I have to tell. What's that? Wants me to do it that way, huh? 0.5. 0.5. All right. So anyway, you can do the rest of them. Numbers program with multiple functions. Okay, so you know, it's a good idea to go through these things to follow it in your follow along the coding in your head. All right, problem below uses this function get numbers to read a number of integers from the user. The 3 unfinished functions are defined, which should print only certain types of numbers that the user entered. Complete the unfinished functions, adding loops and branches when necessary. Oh, okay. So what we want this thing to do is all these things. Let's see. Well, I'm just going to copy this. Copy. And I'm going to put it, and I'm going to, okay, how do I make a new one right up? Can I just make a new one? No, maybe. Create a, oh, okay, I'm going to go back in here because I want to keep them all in one place. And this one is going to be called 6.7.1, I guess. Or something. All right, so it starts out by getting some numbers, user input. Oh, this asks, okay, got it. Okay. So let's start down here. Should always start down here. Numbers, okay, okay, so the first thing it does is it's gonna call this function which says get numbers. Where does size, oh, size is 5, okay. Starts out with size equaling 5, and then it defines some functions here, and we need to finish these functions. We're supposed to print all the numbers with this one. We're supposed to only print odd numbers with this one, and we're only supposed to print negative numbers with this one. Okay, so the first we call this function to ask the user to enter in 5 numbers. And then we're going to print all the numbers with this function. Then we're going to print all the odd numbers with this function. And then all the negatives with this. Okay, so this one works. Wait a second. Oh, I see. We're supposed to enter them all in on one line. All right. And then this returns the numbers. Okay, so I'm going to say, okay, so I'm going to, the first thing we're going to do is print all numbers. And so I'm going to put a, okay, all right, let me just run this first just to see what it looks like. Enter 5 integers, 5, 10, 15, 20, 25, enter. Okay, the first one, oh, I see. So the first thing it does is it prints each one of them. It prints the 0th one, it prints the 0th one, the first one, the second one, the third one, and the fourth one. And then it prints out numbers because that's right here. And here I'm supposed to print out all the numbers. And then I'm supposed to print out the odd numbers here. I'm supposed to print out the negative numbers here. What else does this say? So enter 5 integers, does this, and then it's supposed to list out all the numbers, and then this lists out the odd numbers, and then this lists out the negative numbers. So this is the input. This is the input, okay, to test. All right, let's see if we can get this to work. 122. All right, so printing out all the numbers. How do I get at the numbers? Oh, here are the numbers. This is the array of numbers. This is the array of numbers, isn't it? All right, I'm gonna have to put a breakpoint. I'm gonna put a break. Where do we start? I'm gonna put a breakpoint right. Okay, so this executes, and then let's just put a breakpoint right here. Let's put a breakpoint here. Let me go over here, and let me put a breakpoint. So I'm gonna put another breakpoint here. Now the reason I'm gonna do that is the first time it'll stop will be at line 29, and then I'm gonna use this double arrow, which will just then execute to the next breakpoint. And so when I'm at 29 and it executes to the next breakpoint, it's gonna call get numbers, do all the execution, and then come back and stop right at print all numbers. Okay, so let's so I'm gonna run this. Run. So here we are. We have a size variable because this executed up here, and we're sitting at 29 right here. It says 29. That's where we're sitting, and we're waiting. We don't have a num. We don't have nums yet because we haven't executed. We haven't executed 29 yet. We're about to execute 29. So let's execute 29 by doing this one because I wanted to skip. I just want to execute it and skip over to 30. So I'm going to click this one, and it's asking me for my integers. And I tell you what, I'm going to put in these integers just to copy. I'm going to put these integers in. Paste. Uh-oh. There we go. Hope this works. Enter. Okay, and it does that. It comes all the way, and now it's sitting at 30. It's sitting at 30, and oh, look, here's our nums array because it went in, because 29 executed, and it executed all the way to 30, which means get number is executed, which means all this here executed, all this executed, and we end up, and it printed out, and this is what we see here, printed out, and now we're sitting here, wherever this is, but it's right at 30, and so and here's the nums array, and so now let's just do one at a time. Next step should jump us into here, and then next step jumps us into line 19. You see, here's line 19. So we're in here, we're sitting there, and we can click again, and it's going to print out numbers, and now we're sitting at 30, which is over here, and we click again, and now we're sitting at 31, which is down here, and now we're sitting at 23, and let's just click through. And now we're done. All right, so it looks like right here, we just need to create we just need to print, let's see. for I in range, no, for I in numbers, that's better, colon. I gotta create a new variable called out. Out equals nothing. For I in numbers out. Hand onto out. String of I. str, yeah. I. Followed by a space, I guess. Plus a space. And then here I want to print out. Oops, I got to do a comma. Comma out. So I'm done with my, I don't need any more breakpoints. I'm just gonna, well, let's run this. I want to see what this looks like now. Am I breaking again? I think I'm breakpointing again. Yeah, I am. Let me stop this. I want to get rid of the breakpoints for now. And now let me run this. I'm not doing something right here. Maybe I have to go. Maybe I have to get out of the debugger or somehow. Okay, so here it printed out all the numbers. That's what it's supposed to do. What time is it? I'll finish up real quick here. The next one is to print out the odd numbers, and that would be I'll let you do the odd numbers one. Okay, that's the hardest one, the odd number ones. You have to use mod. Okay, you have to use the percent thing. But for the negative numbers, that shouldn't be too hard. It should be same thing. For I in numbers, colon. Oh, let's create an out variable. Is nothing. For I in numbers, if I is less than 0, then out. Append I onto out, and then I throw a space afterwards. I hope that space is okay. But anyway, so this should do the main. 5 space minus 2 space minus 67 space 9 space 30 45. What does this do? Forgot, what did I do? I forgot to do the string or something. Oh, wait. Wait a second. Oh, I forgot to do this. Got it. See, I mixed the types. You see, unsupported plus for int and string. So I'm trying to add a string to an integer, and it's not working. So I actually want to make this a string. Let's see if this runs now. I gotta say out here. just like up here. 1 space minus 2 space 3 space minus 4 space 5 space, and it gets minus 2 much. Okay, anyway, I gotta go to a meeting. So we will continue this next time, and I will see you next time. Thanks for watching.
Thank you. I see you.
You.